All right, let's jump right in. We're heading into the world of scientific publishing, but it's not what you think. There's a new kind of mystery unfolding, and we're going to see how a journal editor basically has to become a detective, hunting for a ghost in the machine.
So, picture this. You're an editor. A new scientific paper lands on your desk. And as you start reading, it's perfect. I mean, grammatically flawless. The structure is just impeccable. The language is so polished, it's almost unreal. And right there, that perfection, that's the first problem.
See, the game has totally changed. It used to be about finding mistakes. Now it's about spotting a hidden author, an AI that doesn't leave the usual fingerprints. So the big question is, how do you unmask a ghost hiding right there in plain sight, behind this wall of perfect text?
Okay, so our investigation kicks off with what I'm calling the case of perfection. And the weird thing is, the first clue isn't something you find, it's what you don't find. Real science is messy, right? And the writing that comes out of it, it usually sounds human. It's got its own voice, its own quirks, maybe some awkward phrasing here and there. But AI text, it's often just flat, super consistent, almost robotic. And that perfect polished feel, that's the first red flag that tells an editor, hey, maybe I should look a little closer at this.
So, once that little alarm bell goes off, the real detective work begins. The first move? Cracking the linguistic code. Think of it like dusting for fingerprints, but on the words themselves.
Now, your first thought is probably just use an AI detector. Easy, right? You plug in the text, it spits out a score, done. Well, it's really not that simple. And the folks in publishing have learned this the hard way. These tools are definitely not the magic solution everyone hoped for. And here's exactly why. Check this out. Studies are showing these detectors can flag more than a quarter of totally legitimate human-written papers as being from an AI. And what's even worse, they have a known bias. They often get confused by the way non-native English speakers write, leading to a ton of false alarms. So they're just one tiny piece of the puzzle, and a pretty unreliable one at that.
So instead of just trusting a machine, the human editor has to use their own judgment. They're looking for subtle patterns. For instance, AI text can feel repetitive. It uses the same words again and again. Human writing has more variety, more flavor. AI sentences can be all the same length, marching along like little soldiers. But human writing has rhythm. You get short, punchy sentences, then long, flowing ones. It's just less predictable, you know?
And that leads to another huge clue. AI's favorite phrases. Think of them as lexical fingerprints. You know the ones. These kind of empty, formal-sounding expressions. A real scientist might use one here or there, but a paper written by an AI, it's often just stuffed with them. It's a dead giveaway that you're reading a program, not a person.
Okay, so the investigation is leveling up. We're moving past the soft clues in the language and onto the hard evidence trail. We're talking about things you can actually check, stuff that can't be easily explained away. The case is building, and now the editor is looking for proof that the science itself might be fake.
And that brings us to maybe the biggest smoking gun of all, the hallucinated citation. This is wild. It's when an AI, in its effort to sound smart, just makes up a scientific reference. It invents a whole paper that sounds totally plausible, looks completely real, but it just flat out does not exist. I mean, look at this example. You've got the authors, the year, a really sciencey title, a journal that sounds legit, volume, page numbers, everything looks perfect. But go ahead, try to find this paper. You won't. You'll just hit a brick wall. It's a ghost reference. So what does an editor do? They have to perform what's basically a forensic audit of the citations. They'll pick out a random sample and start checking. First question, does this paper even exist? And then, just as important, if it does exist, does it actually say what this new paper claims it says? Because a fake citation is a giant, flashing red light for AI-generated nonsense. Another place to dig for hard evidence is the methods section. See, an AI will describe a procedure like it's straight out of a textbook. Perfect, clean, totally generic. But a real scientist, they'll tell you about the messy reality. They'll name the specific model of the machine they used, where they bought their chemicals, and they'll definitely mention that one experiment that went wrong and how they fixed it. It's that real-world grit that AI just can't fake.
So, at this point, the editor has a pretty strong case. They've got the weird language, they've got factual errors. Now it's time for the final, most critical step, interrogating the lead suspect. And let's be clear, this isn't about pointing fingers and yelling, aha. It's more of a test. The editor will send an email with some very specific targeted questions. They're not trying to trap the author, they're trying to see if they have that deep, hands-on knowledge you only get from actually being in the lab and doing the research. A question like this is brilliant. It's basically asking, tell me a story about when things went wrong. An AI can't do that. It has no experience. It's never been stuck in a lab late at night trying to figure out why an experiment failed. But the person who actually did the work, oh, they'll have a story.
Here's another great one. It's a simple request. Can you send over the raw data and the code you used for the analysis? I mean, if you did the work, you have that stuff. It should be easy to send. But if an AI just cooked up the whole paper from a few prompts, that data might not even exist. And that response, or more often the lack of a response, is usually the final nail in the coffin. If the author gets all evasive, gives some generic answer, or just can't produce the data, well, the case is pretty much closed. It's clear they don't have real ownership of that research. So, okay, case closed on that one paper. It's rejected. But what does this all mean for the future of science? What's the bigger verdict here? What are the rules of the road in this new world?
Principle number 1 is non-negotiable. The buck stops with the authors. Period. It doesn't matter if you used a calculator, a spell checker, or a super advanced AI. If your name is on that paper, you are 100% responsible for every single word. You can't just say, oops, the AI made a mistake. That's just not an excuse. And number 2, it's important to get this right. The goal isn't to ban AI. I mean, it can be an incredibly useful tool for scientists, especially for things like editing or overcoming language barriers. The real goal is just be honest about it. We're seeing journals now creating rules where you just have to say how you used AI. It's all about transparency, not about punishing people. And that brings us to the third and maybe the most important rule of all. At the end of the day, no automated tool or AI detector score can ever replace the brain of a human expert. An experienced editor, a knowledgeable peer reviewer, that's the real firewall. Protecting science ultimately comes down to human judgment and a real commitment to finding the truth. So that leaves us with this final thought. AI is getting scary good at mastering the language of science. It can write a perfect-sounding paper, but real science isn't just about the right words in the right order. It's about curiosity, struggle, integrity, and the thrill of actual discovery. So as the machines master the language, who's left to guard the soul?